So, okay, if you have, okay, multiple dissociation, yeah, pKa, multiple pKa. For example, if you have H2SO4, okay, H2SO4, okay, they can dissociate, okay, you can have H2SO4, they will dissociate to give you H plus and then HSO4 minus. And they can also dissociate further. HSO4 minus, they can dissociate further to give you H plus and SO4 2 minus. So therefore, H2SO4, they will have 2 Kas, okay, 2 Ka. And we can compare these 2 Ka, quite simple, okay, which is going to be, you need to remember the first dissociation, okay, the Ka is going to be always bigger, okay, the first dissociation, the Ka is going to be always bigger, okay, than the second dissociation. So in this case, if you look at this, the first example here, okay, we know that this one will dissociate to give you this. So even though they are dissociating, the value is still going to be low, okay, going to be low. Okay, so let's say this is going to be 1 times 10 negative 5, for example. And because the HSO4 minus is low, yeah, this is going to be low. Okay, what this second equilibrium will do, okay, according to LCP, the Chatelier's principle, the position of the equilibrium will be shifted to the left to increase this concentration of HSO4 minus. Okay, so in that process, okay, when I write down the Ka normally is going to be the reactant, which is the Ka2, yeah, Ka2 is going to be H plus and then SO4 2 minus divided by HSO4 minus. So we normally have this, okay, if it is going to the left, okay, it means this is more, okay, and this is less. So we can say the Ka2 now is going to become less, okay, than Ka1. So we are expecting, okay, the Ka2 become less than that. Maybe I'll just say -8, okay, for example, it's less, okay. So this is going to be a situation where you can predict, okay, the Ka, okay, and we can also mention, let's say, pKa. The pKa of something that has the bigger Ka will be always lower, okay, compared to the one that has the biggest Ka. Yeah, so that is going to be another thing that you need to take note. Okay, so if I put this, okay, in terms of what we have learned, ethane dioic acid, okay, ethane dioic acid. So if you put this in this form, okay, we know that, okay, it has 2 Ka, okay, it has 2 Ka. One is, okay, when you have this CO2, okay, H, and then CO2H, okay, they are going to give you, one of the H will be gone, okay, so if you have this O2 minus plus H plus, okay, and you will have the another one which is going to be OH, okay, O2CC, O2 minus, okay, they are going to give you H plus, okay, and then O2CC, O2 minus minus, yeah. So we will have 2 Ka over here, okay, both Ka. And what is important here, the first dissociation, okay, the first dissociation will be greater, okay. So if I take a value, I just randomly give a value, 1 times 10 negative 5, for example, okay, we know that, okay, the dissociation is little, so this is small value, this is small value. Okay, if you take the small value, I put it over here, this is still small value. According to LCP, Le Chatelier's principle, because that is small, okay, the position of the equilibrium for the second equation will be automatically shifted to the left to increase the concentration of that ion. Okay, and what happens in that process? Okay, Ka, we know this Ka supposed to be the product divided by reactant. And because of the product is going to be less, okay, they are going to be reacting less and then forming more reactant. Okay, we can say automatically the Ka will become lower. So we are expecting this to become 10 negative 8, for example. Okay, so it means the Ka is more here, Ka is less here. Okay, and that will actually make our pKa value. You see, pKa value is less, okay, and pKa value over here is more. Yeah, I hope this is going to be it will clear your doubts on this part. Yeah.